Hello students, welcome back to the video lecture series of numerical methods in chemical engineering. See, we have started unit number 7, that is numerical solution of ordinary differential equations. We have already completed the Taylor series method, then Euler's method. Okay, then today we are going to study about the modified Euler's method. See, in Euler's method we have seen that there are some disadvantages. The disadvantages are there are some errors in the Euler's method. We have seen in that graph that the value of y1, y2, y3 and so on is not exact as the value obtained in the graph. Okay, the value obtained with the formula is different than the value obtained on the curve. So to remove that error, to reduce that error, modified Euler's method is used. Okay, what is to be done in the modified Euler's method? See, I will write the formula of the modified Euler's method. Okay, the only difference is we have to find the approximations of y1 until we get the exact value. What we were doing in the Euler's, we were finding one value, and on the basis of y1 we were finding y2, on the basis of y2 we were finding y3. But here in modified Euler's method we have to continuously find the approximations, and we have to continue until we get the exact value of first approximation, and after getting the exact value of first approximation then we will find the second approximation. Okay, so let me write the formulas for that. The general formula can be written like this: yn plus 1 is equal to yn plus h by 2 f of xn comma yn plus f of xn plus 1 and yn plus 1 star. Now what is yn plus 1 star? See, yn plus 1 star is nothing but the value of y obtained from the Euler's method. So what we have to do first of all we have to find the step number 1. First of all we have to find yn plus 1 using Euler's method. And then we have to find yn plus 1 using modified Euler's method. Okay, and we have to use this yn plus 1 star here. Okay, in yn plus 1 there will be various approximations. For example, yn plus 1 1, this is the first approximation of yn plus 1. To find this, what we will do? Yn plus h by 2 f of xn yn plus f of xn plus 1 yn plus 1 star will be there. In yn plus 1 second approximation we have to replace this yn plus 1 star with the new value. So yn plus h by 2 f of xn yn plus f of xn plus 1 will be same, and we have to take the latest value of yn plus 1. Then again this next approximation, this was the second approximation, then again we have to find the next approximation, and we have to continue until we get the consecutive values of yn plus 1 same. Okay, so this is about the formula of modified Euler's method, and we are trying to reduce the errors with the help of modified Euler's method. So let us take one numerical on the basis of this. See, this is the given numerical. Solve y dash is equal to x plus y of 0 equal to 0, h is given 0.2. okay, h is our 0.2, and we have to find the value of y of 0.4 and y of 0.2. Okay, we have to find y of 0.2 and y of 0.4. So first of all, let us write the given data. F of x comma y is equal to x plus y is given. Okay, h is equal to 0.2 is given. See here, x0 and y0 are given, both are 0. x0 and y0 both are 0. Okay, taking h is equal to 0.2, what will be my x1? My x1 will be 0.2, so I have to find y1. y1 will be y of 0.2. Okay, similarly x2 will be 0.4 and I have to find y2. So I have to find y1 and y2 because we want to find y of 0.2 and y of 0.4. Y of 0.2 is our y1 and y of 0.4 is our y2. Okay, now to find the first iteration, we have to use the initial values. X0 is equal to 0 and y0 is equal to 0. Okay, and I have to first of all find y1 star. How I can find y1 star? So y0 plus h into f of x0 comma y0. What is our y0? 0. What is our h? 0.2. F of x0 comma y0. That means we have to place 0 and 0 here. So my y1 star will be 0. Okay, this is my y1 star. Okay, this is my y1 star. Now I have to find y11. The first approximation using modified Euler's method. So it can be written as y0 plus h by 2. F of x0 y0 plus f of x1 into y1 star. What is our y0? 0. What is our h? 0.2. 0.2 by 2. F of x0 y0. We have already found the value of f of x0 y0, that is 0, plus f of x1. x1 is our 0.2 and y1 star we have already found, that is 0. Okay. See here, you can again use the Kelsey techniques. Okay. Here f of 0.2 comma 0. F of 0.2 comma 0, that means what? The value of x is fixed. And here we have to continuously change the value. So we will start from 0. So instead of 0, let us write answer. Okay, make a formula, make an equation in the Kelsey. 0.1 into 0.2 plus answer equal to, we don't know which value has been taken by the Kelsey as answer. So you have to start from 0. y1 star is 0. So 0 equal to up key equal to. This will be your y11. Okay. Then again press equal to. So the different values of y11, y12 and so on will be, I am writing here. Okay, are you getting it? You have to make an equation and we are just changing the value of this. Okay, y1 star. So we have to start from the value of y1 star. y1 star is 0. 0 equal to up key equal to, this will be your y11. Then again equal to, this will give you y12. Again equal to y13. Again equal to y14. And you have to continue this until you get the same answer consecutively. Okay, so let me write the answers. See, my y11 will be 0.0200. Then y12 will be 0.0220. Then y13 0.0222 and y14 will be also 0.0222. That means what? The two consecutive values are same, so we can say our y1 is 0.0222. Okay. Now using this x1 and y1, we have to find y2. Okay, this is our final answer for y1. y1 is our y of 0.2. So what is our y of 0.2? Y of 0.2 is 0.0222. Okay, now using this, we have to find the value of y2. How we can find the value of y2? Let us see that. Let me erase everything. See, to find y2, first of all we have to write the value of x1 and y1. What is our x1? x1 is 0.2 and y1 is 0.0222. So first of all find y2 star. What will be y2 star? y1 plus h into f of x1 y1. So what is our y1? 0.0222 plus 0.2 into function value. Function value means 0.2 plus 0.0222. So my y2 star will be 0.0666. Now I have to find y21. So what is the formula? y1 plus h by 2 f of x1 y1 plus f of x2 and y2 star, and then I have to continuously change this value. So after making the equation in the calc, you can get y21. So what will be our y21? Our y21 will be 0.0911, then y22 0.0935, y23 will be 0.0938, and again y24 will be same 0.0938. So this is our final answer. See, you can see here that we are continuously finding the approximations until we get the exact value. So in this way we can reduce the errors that are present in the Euler's method. Fine. One more thing about Euler's method. Euler's method is also known as RK second order method. Euler's method is also known as what? RK second order method. Okay. Now let us study RK fourth order method. Rajkut fourth order method. See what we have to do. We have to only remember the formulas. Yn plus 1 can be written as Yn plus k, where k is equal to, k can be written as h by 6 k1 plus 2k2 plus 2k3 plus k4. Why it is known as fourth order? Because we are taking 4 different slopes. Okay, in second order we are taking 2 slopes. In RK, Rajkut fourth order method, you have to directly remember this. Okay, Yn plus 1 is equal to Yn plus k. And how we can find k? So this is the formula to find k. Okay, h by 6 k1 plus 2k2 plus 2k3 plus k4. Okay, and after that we have to first of all find the value of k1. How we can find k1? See, k1 can be written as f of xn comma yn. It is the slope at the beginning of the interval. Okay, then I have to find the midpoint slopes. Okay, and that can be written as f of xn plus h by 2 and yn plus k1 by 2. We are using the first slope. Okay, again f of xn plus h by 2, yn plus k2 by 2. Okay, and the last is f of xn plus h and yn plus k3. So to solve the numericals, you have to start from here. First of all find k1, then k2, k3, k4. Okay, then place all these values in k and then place in this value. Okay, so if you want to find y1, then y1 can be written as y0 plus k. In place of xn, yn, you have to write x0, y0. So in this way you can solve the numericals of Rajkut fourth order method. There is no need to remember the proof. Directly you have to remember the formulas. Okay. So let us solve a numerical on the basis of this, and this is the last numerical of our syllabus. Okay, let me write the numerical. Use RK fourth order method to solve dy by dx is equal to minus xy square, where the range of x is 0 to 0.5. Okay, and y of 0 is equal to 2 is given. Use h is equal to 0.25 and find the solution. How we can find the solution? See, here we have to find up till which step. X0 is equal to 0, y0 is equal to 2 is given, h is our 0.25. Okay, so what will be our x1? X1 will be 0.25 and we have to find y1, and x2 will be 0.5 and we have to find y2. Okay, now to find y1, what is our formula? See, I am just writing the formulas. You have to solve the numerical by yourself. Y1 is equal to y0 plus k. Okay, y1 is given y0 plus k. Y1 is equal to y0 plus k, but for finding the value of k, you need to remember this formula, h by 6, k1 plus 2k2 plus 2k3 plus k4. So first of all, we have to find k1. How we can find k1? H into k1 can be found by f of x0 comma y0. What is our f of x0 comma y0? See, you can place the values 0 and 2 in this. The value will be 0. Then k2. K2 can be found by x0 plus h by 2. See, h by 2 is separate, not with this. X0 plus h by 2 and y0 plus k1 by 2. If you will solve this, you will get the answer minus 0.5. K3, f of x0 plus h by 2 and y0 plus k2 by 2. Solve it, you will get the answer minus 0.4692. Okay, fine. Then what we have to do? Find k4. What is the formula for k4? F of x0 plus h and y0 plus k3. Okay, x0 plus h, y0 plus k3. Find the function value. The function value will be minus 0.8861. Now you have to place all these values in this equation, so you will get the value of k. So what is our k? After placing all these values, okay, y0 plus k, so my answer for y1 will be 1.8823. Okay, my y1 will be 1.8823. Now using x1 and y1, okay, using x1 and y1, you have to find the values of y2. Okay, how we can find the value of y2? So for y2, the formulas will change. What we have to use for y2? In place of x0, y0, we have to take x1 and y1. Okay, so let me erase this. We will solve it. Okay, to find y2, we will be having the value of x1 and y1. What is our x1? x1 is 0.25 and y1 we have obtained, that is 1.8823. Okay, this you have to solve it by yourself. the formula will be y2 is equal to y1 plus k. K will be h by 6 k1 plus 2k2 plus 2k3 plus k4. Okay, k1 will be f of x1 y1, then k2 f of x1 plus h by 2 and y1 plus k1 by 2, then k3. What will be k3? F of x1 plus h by 2 and y1 plus k2 by 2. Okay, and k4, that is f of x1 plus h and y1 plus k3. Solving this and by placing all the values, you will get the final answer. So my final answer y2 after placing all the values will be y2 is equal to minus 1.2800. Okay, so this is my answer. Fine. See, there are more numericals given in the question bank on the basis of this methods. Okay, you have to do more and more practice. Here we complete our syllabus. If you are having any type of doubt, then you can ask me personally. Okay, best of luck for your exams. Do some practice and gain some confidence. Okay, students, bye bye.